All right, we're in section 3.3 where we're going to prove uh, lines are parallel. So, still discussing our talking points about transversals, and one of the things that was brought up in 3.2 was anytime uh, two lines are parallel with the intersection of a transversal, certain angles were congruent. Um, Corresponding angles were congruent, alternating interior angles were congruent, alternating exterior angles were congruent, and the other item for talking points, it was consecutive interior angles were supplementary. So what we're going to do here is talk about the converse of those things. So the postulate theorems from 3.2 stated that like if if those two lines are parallel, then corresponding angles were congruent, or alternating interior angles were congruent, or alternating exterior angles were congruent, or consecutive interior angles were supplementary. So we're just going to use the converse, means we're going to flip the hypothesis and conclusion to help us prove if those two lines are parallel. So looking at the converse here, we can state that if two lines of a transversal and the corresponding angles are congruent, then we can say that they are parallel. Okay. So again, like I said, it's talking about the conditional statement in reverse, the converse of it. So if we know that angle 2 is congruent to angle 6, then we can say that those two lines are parallel. So right here, it's stating that they want us to find the value of x that makes line A and line B parallel. So for these two lines to be parallel, here and here, these are corresponding angles. Since they're corresponding angles, for the A and B to be parallel, those two angles must be congruent, so they must be equal to each other. So to find x, we are simply going to take 2x plus 3 and set it equal to 71. Subtracting 3 to both sides, I get 2x equals 68. Divide everything by 2, x equals 34. Same thing goes here, corresponding angles with 5x minus 7 and 98. I can say that 5x minus 7 is equal to 98. Add 7 to both sides. I get 5x equals 105. Divide everything by 5. X equals 21. And then here are the other converse theorems that again can help us determine if two lines are parallel when they're intersected by a transversal. So we got the alternate interior angles converse, which again states that if the alternating interior angles are congruent, then the two lines are parallel. Same thing here, alternating exterior angles. If the alternating exterior angles are congruent, then the two lines are parallel. Over here, if the consecutive interior angles are supplementary, then the two lines are in fact parallel. So we can use those theorems and postulates to help us create proofs and determine if in fact two lines are parallel. So looking at this first example here on this page, we have a diagram here. They want us to prove that A and B are parallel. So if A and B are parallel, something has to hold true with one of those converse theorems. So what we are given is we are given 113 degrees and we are given 67 degrees. Those two particular angles have a relationship that they are consecutive interior angles. So since they are consecutive interior angles, they have to be supplementary. So we have to check if 113 plus 67 equals 180. And if you would check, they absolutely do equal 180. So I can say yes, A is parallel to B. My explanation is because supplementary angles uh, because supplementary angles equal 180 degrees, then A is parallel to B. All right, so if we look here, we have a two-column proof. We are given some statements. We don't have any reasons given to us, so we have to kind of find those. So if we look here, the given was that A is parallel to B, which makes sense because we have the arrows, and angle 1 is congruent to angle 3, which they give the hash marks to. So if you look here, you notice that angle 1 is equal to angle 3 is statement 3, so that's a given because that was given to us. And statement 1 is going to be A is parallel to B. That is also given. All right, so at the end of it, we have to prove that angle X is parallel to, or not, line X is parallel to line Y. So looking at the first statement, it's telling us that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. If you look here, if you look at angle 1, it's top right. Angle 2 is top right also. I could say that corresponding angles is my reason that those are um, congruent. All right, we already said that statement 3 is um, given. Statement 4 says that angle 2 is congruent to angle 3. Now, the reason for that is the transitive property. If you remember that whole thing with like A equaling B and B equaling C, then A equals C, that's kind of what it is here. So since 1 equals 2 and 1 equals 3, well then we can say that 2 equals 3. And then the last one is going to be the proof y or x is parallel to y. And the reason why we can say that is now that we know that 2 and 3 are congruent, 2 and 3 are corresponding angles. So we can say that because of corresponding angles, we know that x is now parallel to, it's from the converse. So there's we've been dominantly looking at two-column proofs. There is also another type of proof that we can look at, and that is a paragraph proof. Paragraph proof is just a proof written in paragraph form. So very similar proof that we have here, but so a little bit of changes. The only difference is looks like on the previous page, angle 3 was right here. Now it's on the other side of the angle. So we just got to keep that in mind. So for the most part, it should be relatively similar, but we just have to make some minor adjustments here. So if we look at this statement, it says, it is given that A is parallel to B. So by the blank, angle 1 is congruent to angle 2. So angle 1 and angle 2 are congruent. We can say that because they are corresponding angles. All right, so by corresponding angles postulate, we can say angle 1 is congruent to angle 2. It is also given that angle 1 is congruent to angle 3 right here. Then blank by the transitive property of congruency of angles, we can now say that angle 2 is congruent to angle 3 by the transitive property. Therefore, now if I look at 2 and 3, those are alternating exterior angles. Since they're alternating exterior angles and they're congruent, we can now say that x is parallel to y. Okay? And that is being able to prove lines are parallel. Hope this helps. Till next time.